demonstrate using this little prop. When the solar system was formed, it was formed from this great big disk of dust and gas. So everything in the solar system, when this dust and gas solidified into the rocky planets and the gas giants and the ice giants, everything was perpendicular to the plane that the planets eventually orbited in. So Uranus would have started out like this, as did the Earth and all the other planets. At some stage in the distant past, and probably soon after its formation, something hit Uranus, and from going like that, it ended up with an axial tilt of about 98 degrees. So it's now revolving like that. And of course it's often described as rolling around the sun, and that's what it does all the way around the sun. The Earth doesn't have quite so pronounced an axial tilt, it's just 23.5 degrees. So the Earth is going round like that, whereas Uranus is just over 90 degrees, and it's actually rotating about its axis in that way. This is very unusual, and it leads to, a lot of considerations about its weather. The Earth's seasons and weather are all based on our axial tilt. Sometimes the northern hemisphere is tilted towards the sun. That's our summer in the northern hemisphere and the winter in the southern hemisphere. And as it goes round, we go past the equinox, where it's neither tilted towards or away from the sun, and then back round the sun to winter, where the northern hemisphere is away from the sun. That's our northern hemisphere winter and the southern hemisphere winter. But it makes you wonder what on earth the weather would be like on Uranus that's tilted with often its axis pointing towards the sun. It takes 84 years for Uranus to actually orbit all the way around the sun and back, whereas the Earth does that in just 1 year. So, for a lot of that orbit, its axis and its north pole is pointing directly towards the sun. And the equatorial regions are getting very little sun. Now that's interesting because it was in that position when Voyager 2 actually flew past it. It had got its southern axis pointing directly towards the sun. And what Voyager 2 didn't see, which it expected, was a lot of weather patterns on the surface. As we see all the time with Jupiter, we see these lovely bands and vortexes and the great red spot. But Uranus at that time in 1986 was quite bland. There was no cloud structures. It wasn't realised at the time, but that was a phenomena of this position in the sky. Later on, as it got a quarter of the way around its orbit, in about 2007, the Hubble Space Telescope was looking at it, and a lot more weather features started to appear. So, depending on where it is in its orbit, dictates the sort of weather patterns. And it does have weather. It has winds of up to 800 miles an hour. They're largely hidden by the atmosphere, but using different wavelengths, such as infrared, we are able to see these now. But unfortunately, Voyager 2 didn't get much of a look at them. So that's the axial tilt of Uranus. It's almost on its side, and it's like rolling around the sun in its 84-year orbit.
Since